Here is the Chapter 4 Test Review Study Guide. Problem number 1. First I see the parentheses, which is telling me that this fits the form y equals a times x minus h squared plus k. So the vertex comes from the h and the k. So it's x minus h. So I'm doing the opposite of what the equation looks like inside the parentheses. So the vertex is negative 5 for the h value. Think of it as x minus negative 5 to make x plus 5. And the k value is plus k, so it's plus 4. So negative 5, 4 is the vertex. The axis of symmetry is the equation. So if you think about a graph at negative 5, 4, the axis of symmetry is going to be this vertical line that goes through the vertex. So it's going to share the x coordinate. Therefore the axis of symmetry is x equals negative 5. Does this graph have a minimum or maximum? Well, I look at the a value and I see that it's positive, which means that it will open up, meaning that the vertex is the lowest point on the graph. It is a minimum, and its value is always the y coordinate of the vertex, which is 4. Finally, the domain in a quadratic equation, the domain is always all real numbers, so from negative infinity to positive infinity. The range, think about the y values, the lowest point on the graph is at the minimum value. The minimum is 4, and we use a bracket around the 4, and then it goes forever going up, so it is to infinity with a parenthesis for the range. Now, one thing that I just discovered on the calculators in class is that there's an option for finding a table on here. So when you turn it on, and right here next to the clear key it says table. If you press table, it allows you to enter an equation. I'm going to clear out the equation that's in there right now, and our equation in this case is 7, and then the parenthesis and the x. So down here at the next to the number 4 is all of our variables, so we just press that button to get an x. And plus 5 close parenthesis, x squared is next to the 7 to get the exponent, and then plus 4 finishes off the equation. And when we press enter, it allows us to say this is where the table will start as an x value. It's going to increase by 1s, and it's automatically going to fill in the numbers. So I just press enter and OK. Hit enter one more time, and we see the x values and the y values, that when you put negative 2 into that equation you get out 67. Well, if I go towards the smaller numbers, eventually I see here the y values repeat. There's a smallest y value, and then the y value increases on either side of it. And so negative 5, 4 is our vertex, because that's the place where the repeating happens on either side of it. The 11 is on either side, then it goes to 32, the other direction it goes to 32. And so this is a way to get values if you need to graph, and it's also a way to find the vertex based on the symmetry that is around that vertex. We'll use it on the next problem too. Number 2. This equation is in standard form, so it looks like y equals something times x squared plus something times x plus something else. In this case, in standard form, the axis of symmetry will be the easiest to find. And that comes from x equals negative b over 2a. Remember, this is the first part of the quadratic formula, which is on the formula sheet. So my b value is the number next to the x, which is 6. So I do the opposite of 6 over 2 times a, and a is the number in front of x squared. There's a negative sign there, so that's the same as a negative 1. So negative 6 over 2 times negative 1, negative 6 divided by 2 times negative 1 is negative 2. Negative 6 divided by negative 2 is positive 3. So the axis of symmetry is x equals positive 3. Now remember from the previous problem that the axis of symmetry goes through the vertex, so our vertex must have an x-coordinate of 3. So to find the y-coordinate, we can use our calculator, or we can just plug 3 into this equation. So y equals the opposite of 3 squared plus 6 times 3 minus 7. 3 squared is 9. Exponents come first, then make that answer negative. So negative 9, 6 times 3 is 18. Negative 9 plus 18 is 9. 9 minus 7 is 2. So the y-coordinate of the vertex is 2. So to check that on the calculator, I'm going to go to the table up next to the clear key. I'm going to clear out the equation, and I'm going to enter this new equation. So the negative key is right next to enter, the negative sign inside the parentheses. Then the x variable is right next to the number 4. And then squared. So just to show you that, so I did negative, and then x, and then squared. Then plus 6x minus 7. And so then when we hit enter, it gives us a chance to choose where we start. I'm just going to leave it there and say OK by clicking enter a bunch of times. And now I'm expecting 3, 2 to be my vertex. So I'm going to go down, use the arrow key to go down until I get to 3, 2. And so the x value is 3, the y value is 2. Notice the symmetry. On either side of that 2, the numbers are the same for the y value. So, is that 2 the largest number or the smallest number? Is it the minimum or maximum? Well, the numbers on either side of it get smaller. They go towards the negative numbers. Therefore, this is the highest point on the graph. If we look at the equation, we see a negative a value, which means that the graph has a vertex at 3, 2, but it is going to go down because it's a negative a value. That means 3, 2 is the highest point on the graph. It is a maximum. The value of that is what is the y-coordinate of the vertex? How high is that point? It is 2 units above the x-axis. So the maximum value is 2. Domain for every quadratic equation from negative infinity to positive infinity. The range Well, this one opened down, so its lowest value is negative infinity. Its highest value, the top of the graph, is at positive 2, and we use a bracket with positive 2. Okay, next, number 3, graph the function, state the transformations. So in this problem, I need to know the vertex, and so x minus h squared plus k. So my h is 4, the k value is negative 2. So that is the vertex. So I plot the point 4 to the right, negative 2 goes down, put a point there for the vertex. And then I'm going to use the a value, which is 2. And this is where we use the 1, 3, 5, 7 and multiply each of those values by 2. So 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10, and so on. And so when I go over to the right or to the left 1 unit, I'm going to go positive 2 units. So I'm going to go up 2, right 1, up 2. Left 1, up 2. The next number is a 6. So the next time I go over 1, I'm going to go up 6. So from here I'm going to go right 1, up 1, 2, 3, 4, 5, 6. Do the same thing to the left. Left 1, up 1, 2, 3, 4, 5, 6. The next time I go right 1, I'm going to go up 10. Well, that's going to go well off the graph, so I'm going to stop with these 5 points and then try and draw as smooth of a curve through those points as I can, trying to make that bottom of the curve rounded. And there is the graph. Just to confirm my points, I can go to the calculator and go to table. I'm going to clear that equation and enter in the equation that I'm given. So 2 parenthesis x minus 4 and squared, oops, not yet, gotta use the arrows to go back and put my parenthesis in there. Parenthesis, then comes my squared. And I want to delete that accidental, and now when I press the arrow over, now it gets back so I can enter my minus 2. Okay, so when I hit enter a few more times, okay, and I see 5, 0 should be a point on my graph, 6, 6 is a point on the graph, 7, 16 is off the graph. If I come the other way, I see 4, negative 2, and 3, 0. Notice if I had plotted these points, I could tell my vertex is right in the middle of those, and 2, 6. 1, 16 goes off the graph. So we can use the calculator either to help us plot the points or to check our answer to be at the end. Either way, I'm sorry I didn't see this before. It's a function I hadn't noticed on these calculators. The final part of this is to state the transformations. So the first thing is the vertex. Move the graph 4 units to the right and 2 units down. So we could describe this as shift 4 to the right and 2 down. and then the a value of 2 stretched. So we stretch by a factor of 2. So everything was made taller or narrower by that factor of 2. Hey, number 4. Which of the following is the graph of y equals negative x squared minus 4x minus 3? I see that my a value is negative, which means the graph should open down. So I already know that it's not going to be number 1. But which of the other 3? I need to find something about the vertex. So I could use the calculator and enter the equation in, or I can use my axis of symmetry since this is in standard form. So think of this as A is negative 1, B is negative 4. So the opposite of B, so the opposite of negative 4, over 2 times the a value, which is negative 1. The opposite of negative 4 is positive 4. 2 times negative 1 is negative 2. 4 divided by negative 2 is negative 2. So I know my axis of symmetry is at negative 2. So axis of symmetry goes through the vertex. Graphs 2 and 3 have that, graph 4 does not. So I'm down to 2 and 3. I see the main difference looks like how high the y value is, the maximum value. So now I want to take that negative 2 and put it back into the equation to find what is the y value at that point. So I'm going to take this equation and say y equals the opposite of, now I'm putting negative 2 in for x and squaring it, minus 4 times negative 2, and finally I need to subtract 3, which I'm running out of room for. Negative 2 squared is 4, positive 4. But then I have this negative sign outside will make it negative. So that becomes negative 4. Minus 4 times minus 2 becomes plus 8. And then subtract 3 from that. Negative 4 plus 8 is 4. 4 minus 3, positive 1. So I'm looking for the vertex at negative 2, 1. Which means that it is graph number 2. The other thing to notice here is that if I put 0 in for x, this is 0, 4 times 0 is 0, minus 3. So when x is 0, y is negative 3. So if you look for that y-intercept, the c value is always the y-intercept. Just an additional piece of information to look for. Again, we could use the calculator and go to table, clear the equation out, enter the given equation, negative next to the enter key, then comes the x next to the 4 key, squared next to the 7 key, minus 4x next to the 4 key, minus 3. When I hit enter, 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 OK, I see 1, negative 8. That looks like it matches pretty well in the graph. 0, negative 3, that works. Using the up arrow, negative 1, 0 is on the graph. Negative 2, positive 1. Negative 3, 0. Negative 4, negative 3. And so we can confirm that that equation matches this graph. matches the points on the graph. I'm going to skip to number 9 at the bottom of the page, since this is the related equation. Write the quadratic function in vertex form based on the given information. So vertex form is y equals a times x minus h squared plus k. We're given the vertex, which tells me my h and my k value. The extra point is just an x and a y value that are found somewhere on the graph. And so by plugging these 4 numbers in for y, x, h, and k, we then will have an equation with just a that we can solve for a. So I'm going to put -7 in for y. I don't know a. X is -1. Minus h is -2, so I'm subtracting -2. Well, subtracting a negative is the same thing as adding a +2. I'll do that on the next step. I keep the squared plus the k value is -4, or subtract 4. So now I want to simplify this for a. So first of all, I do everything in the parentheses. Order of operations, parentheses come first. -1 plus 2. -1 plus 2 is +1. Then comes exponents. 1 squared is still 1. But now multiplication comes next, and order of operations doesn't allow me to multiply the variable times 1. So now I'm ready to solve to get a by itself. So I need to get rid of what's being added or subtracted first. So the opposite of adding -4 is to add +4. So I go to the other side and add +4. So my next line, -7 plus 4 is -3. A times 1 is really just a. 1a is a. -4 plus 4 is 0. So my a value is -3, which means my equation is going to use y and x as variables, as the letters. So y equals, my a value is -3, x minus the h value. So minus -2 becomes x plus 2 squared, plus -4 is same as -4. And so that is the quadratic function in vertex form.